So here we see the result of the projection to bottom I've just made with this slide projection. And then I will insert it into the temporary projections file. And I will go to options. And here in options you can see I can either project from survey, from current survey, or project from last projection. If I project from current survey, it will wipe out whatever projections I made and start from scratch. If I project from projection, it's pretty much self-explanatory. So I will project from projection, and this time I will choose the 2D, 3D projection routine. And what this projection routine does is it assumes that to reach the target you will need either one or two curves, either separated by a straight section or not. And you can set up this routine to quite a variety of profiles. So I press 2D, 3D, and my first question is project to another well path, and you say no for now. And project parallel to the vertical section plane, you say yes. And this is recommended that you do that whenever possible, rather than try to make a 3D projection. For example, in this case, we could make a 3D projection to try to reach the center of the target, even though we're 40 somewhat meters to the left. But that would require a huge dog leg, which is impractical. So at this point, we have decided that we are going to go straight, since going straight will still put us in the target. And if we can, in the next few meters, we can try to bring it a little more to the right. So anyway, we can change, if we want, the plane along which the projection is made. In this case, we're not going to do that. And if we go straight rather than continue with a well direction at this point, that will incur a instantaneous 2D dog leg of 1.98. In other words, the well is going at 70.1, and we want to go to 72.3. So at nearly at 70 degrees, that represents a dog leg of 1.98. So we accept it because we figure we can turn the well a couple of degrees to the right by the end we hit the target, so that's no problem. So we say yes, and then here we have the target, which we are not going to displace now. I will displace it later to demonstrate some other things, but for the time being I will leave the target where it is. And the first uh, the first plan I will make, the first projection I will make will be a J well. In other words, I will try to build at a continuous rate, which I don't know what it is, so I put a question mark here. I'll build at a continuous rate, and then hold at 90 degrees. Now, if it were possible, we would hit 90 degrees at the TBD of the target someplace before it or exactly at it, but this is not the case now, because if we press enter and we enter a 0 for the second curve, because there's none, it's just a build and hold, it will try to create the plan, but we get you see here the desired inclination is 90 degrees, and we press and we see that with a build-up rate of 4.56 and the second curve non-existent, we will overshoot the vertical section by 7.2 meters. In other words, we will overshoot the target entry point by that amount. So although that's not very much, and in real life terms, we probably live with that, no problem. I will show you how you can make another type of projection with this same routine that will hit the target exactly. So I press continue, and it cannot converge because it tried to set the slant, and but we're already in the target, so it cannot converge. So I will now start from scratch again. Start, project another well path, no. Project parallel, yes. Enter new projection plane, we leave it like this. Instantaneous, I leave it like this. Okay, so now I will change the target. I will displace it by 50 meters, so we only have one target, drain. And I will displace it out 50 meters, so you see what happens. we should be able to make the target. The landing point is further out. So we say okay, and here are our new coordinates, and we're 47.5 meters left offset from plan line. Okay, and the first prompt is still a question mark. The second prompt is 0 because it's a straight line, and we want to land at 90 degrees. And we see that we at 4.56 degrees we will start the hold at 2033.59 meters measured depth, and we will hold for 42.77 meters. Remember, before we overshot the target by 7 meters. Now we are going to undershoot the target by 42 meters because I have displaced the target by 50 meters. So you see, in this case, it would work. And the other way, it tells us that we are going to overshoot the target, and if we don't want to do that, we got to do something different. Okay, so I say continue, and I will go from start again because what I want to do is remove that that offset which I put there, and I change it, and okay, and 0, enter, and okay. So we're back to the target as it originally was, and continue. So we know that the plan calls for a build-up rate of 4.5, and we know that we're 1.3 degrees behind in angle. So if we build at the proposed rate, we will be getting closer and closer to the plan line and at some point we might touch it, and then we will have to use a higher dog leg to actually hit the target. So I will first make an attempt to calculate this thing with a 4.5 initial build-up rate, and the second build-up rate is unknown, so I put a question mark, and I press enter, and the desired final inclination is 90, and you see that we end the first build-up at 2,432 meters, and the build-up rate is 4.5 as we specified. We'll do that for 122 meters, and the inclination will be 85 degrees at that point, 85.33, and the azimuth, as it should be, 72.3. Then there's no whole section between the two curves. One curve is conjoined to the other, and then the end of buildup is at 2026, and with a buildup rate of 6.34 and a course length of 22.08, and we hit the target exactly at the drain entry point. We're not very happy with the 6.34, it's too high. So I'm going to try something different, slightly different, see which way these things go. Let's say I change the first dog leg, I call it, let's say 4.2, and leave the next one still a question mark, 90 degrees at final inclination. So here we are at the result screen for this two curve build up into the target with the initial build-up rate of 4.2, and the program calculates a second build-up rate of 5.18, which is acceptable. So we press continue, and we press append, and we go to options, and we view all the projection points we've had up to now. So 1863 was the tie on, which is the last survey. Then 1882 is bottom, and then 1882 again is bottom, but this time with the azimuth changed to be in line with the vertical section or the plane of proposal. And then we build to 1941 meters to 75 degrees in the same direction, and then we end the build 2026, 90 degrees, 72, continue, and we can go to options again, and we can view the last one.